Hi everyone. So today we're going to cover the machining edition of 𝗶𝗰𝗀. So machining today we'll cover the materials overrides. We'll talk about the machine properties, the tooling, also the best practices for parts moving on the machine. So if you have small parts, if you have to find a different tool strategy for your machining, we'll discover how to do that. Also, we'll at the end also discuss DXF import in 𝗧M. So how to properly import a CAD file in the 𝗧M and have it ready for machining. So let's start with first the machine properties in 𝗶𝗰𝗀 and 𝗧M. So today I'll be using version 2024, but the same would apply to most versions of 𝗶𝗰𝗀. So to access to my 𝗧M, I'll go back to my report view, and the 𝗧M, of course, is the 𝗧M tab in your tab view at the top. 𝗧M center, you will always be importing parts. So the part list is where 𝗧M is importing the part with the materials and the operation associated with the parts. So to access the machine catalog, that will be at the very top in the catalog toolbar, and you have the machine button. So that's where you can change properties on each machine you might use for your optimization. So most of those settings would be set during your machine integration with a technician, but there's a few that you can adjust if needed. The very first one, you might sometimes want to wonder how to change the output directory. So that's first by selecting the machine you want to modify. And in the general tab, you have output directory option where you can change the location of the files being output by 𝗧M. Keep in mind some machine, the way they are integrated, you have to stay in a specific location. So if you're unsure or if it's creating issue, just reach out to a technician just to see if there's any problem changing the output directory. The next thing is in the output tab. We'll cover really like the most important thing to modify if you have an issue with your machining. Most of those settings are already set. So as I said, don't go and change everything here because you will have a dramatic impact on the way 𝗶𝗰𝗀 is outputting your file to this machine. But the one that's safe to change will be first in the nesting group. So in the drop-down list, I select nesting. The very first one you want to check is your nest type. So you have two options. You have the option to do a block nesting or a true shape nesting. So the block nesting will see a part as a rectangular shape. So basically, 𝗶𝗰𝗀 will draw a rectangular shape around your part to define the boundary of it, and then use it as a placeholder to place this part on the nested sheet. Whereas true shape is going to follow the true shape of the outside edge of your part. So it's very useful, of course, if you have some angle cabinets, some curved cabinet as well. The impact is very big for shape part, not so much if you just do regular boxes. You most likely have a similar yield, but if you have a lot of shape part, I would recommend to switch to true shape. If you're unsure and if you go back and forth, it's safe to keep true shape as a daily setting. It's not going to have any impact other than being a little bit slower to optimize than a block nest type. So for example, if I go with my block nest type, and click close, I will just create an example. I'll filter some parts and find some curved parts. Click OK. In my filter, so they'll be selected in my part list. I will click optimize to optimize on my default router and run this. So right now, I already see in the summary that I will have a total of 3 sheets, and this will give me not a good optimization. You can see that you're losing a lot of space around the curve just because this is a block nesting. So right now we have 3 sheets. And of course, if I go back and switch to a true shape nesting, back to in my output tab under nesting, and this time I will switch to true shape and optimize the same parts. I should have a much better result. And as you can see here, we're talking just about a few parts, so the difference in time is not much. Right now, I save an extra sheet, so right now I have 2 sheets, and now this is much better and much more what I would expect it to be. As you can see, very little space wasted on this optimization with the true shape nesting. So that's really what true shape does. The other impact of true shape is for small parts. So if I go back to my machine catalog and keeps the same machine. So right now what we change is the nest type to true shape. So when you have true shape, another thing you can set for small parts, it's in the small part group. When you scroll down to the very end, you can set the true shape nest boundaries. So the true shape nest boundaries allow you to have the small part to be outside a specific distance from the exterior of the sheet, or to be placed in a specific corner of your nested sheets. The small part and very small part size are defined in the part size group of the small part section. So you can set the width of the small part and the width of the very small part. And the reason why you have 2 different options is just to give you 2 different settings. So you can set a different boundary for small part versus very small part. And the same way also you can change the lead type for small part and very small part. My recommendation, a setting that works well, is for the lead type for your normal part to keep a slope lead in and lead out. So basically the tool will lead at an angle and exit the material at the same angle. And for small part, the return onion skin will actually create 2 passes. The first one is not going to be a through cut. So first, S2M is going to cut the first pass of all the small parts or very small part, depending on your sizes, where it will leave a skin. And the skin thickness is defined and the onion skin thickness. And then if you use the return onion skin, the second pass will be done after the outline pass. So it's not going to cut through right away. It's going to start out cutting the other part and then come to the small part to cut the skin. So we will try to keep them on the board as long as possible versus cutting them right away if you just use onion skin. So onion skin will create pass 1 and pass 2 right away, where return onion skin will create pass 1, cut the other normal parts, and then cut pass 2 of the small parts while cutting the normal parts, depending on the way you have your nesting machine set. So something to set properly is the small parts and the very small part size. So I would say everything around 4 or 5 inches would be good for a small part, and a smaller value for very small part if you want a different behavior for very small parts. You have also an option to create tabs. The tab means that CAMvision will cut through most of the part but keep a bridge on each edge of the part to keep it attached with the other part with what we call a tab. Keep in mind this tab will always create a second pass to at the very, very end to create a cut through outline cut that will remove the tabs to actually release the parts from the nested sheet. So this is the tab that you could use if you wanted for the very small part. But usually with return onion skin, you should have good result. And if you still have issue, you can also play while using true shape nesting with the exterior boundary for small parts. So you can offset them a couple of inches from the edge, because typically the vacuum seems to be less efficient at the edge versus at the center of the sheet. So you can use the setting to have those parts to be toward the center of the sheets. In the machine catalog, another setting you can change, it's back in the nesting group, will be the outline start point. So the default setting will be a center outline start point, where CAMvision will pick the middle of one of the edge of the part as a lead start point. And if you set the link part outline to yes, then you will create one single toolpath to cut your entire sheet. This one is really the best you could use because it will have a lot of benefits. First time, it could go all the way to 20 to 30% faster to use the link part outline versus cutting individual part with individual lead in and lead out. So time is one thing. The second one also is the quality of your machining. You only leading one time with the link part outline, so there's less chance that once you lead in and lead out on the part, it get damaged. Usually that's where you could see a little slope on the part, a little bump. So with the link part outline, you minimize this where it's only happening on one part. And the last one also, you will extend the tool life. Again, less lead in and lead out means less stress on your tool. Usually the tool get the most stress when you lead in into the material, so you're minimizing this. So you should also have to change your tools less often. So that's why it's a win-win situation to use the link part outline. And this one will work with the center outline start point. If you have a lot of problem with small parts, you can also use under the outline start points selection a perimeter cut. So the perimeter will have the actual outline start from the outer edge of the sheet and working toward the center. So because the vacuum is not very good at the edge of the sheet, so you cut those parts first to avoid them, to avoid having them moving during the machining, and then slowly CAPGen will cut toward the center of the sheet. So that's what it is. Corner and near corner, it's more a strategy where the tool will lead in the corner of your part. Also to note that perimeter will not allow you to use link part outline, and also corner as well. Only center will allow you to use the link part outline. So this gives the software more flexibility to be able to find the optimal path to link all the parts together. Whereas if you restrict it to perimeter or corner, some scenario it would be impossible to link them all in one single toolpath. So that's why. So those are the things that you want to check. Usually by keeping center and link out part line set to yes, that will maximize the chance of having good machining and also less part moving as well. The other thing also we introduced recently is the offcut, the square off sheet for offcuts. So this before was found in the optimizer parameter, but now it's a machine setting. So now at the machine level and for each machine, you can turn on or turn off the square off machining for your offcuts. So this one will simply create a line to actually square off your material, where this outline offcut will really trim around it, and you can define the trim you want to remove around your offcut and the margin for the offcut as well. So typically I would only keep the standard square off for my offcut. That would be just to make them easier to handle once the program is done. So those are the settings that will really make an impact on the way your part will be cut. Another one under IntelliCam, and this is one more to control the approach offset. So when you're leading onto a part under IntelliCam, you have an approach offset value. So make sure this value is always positive because you want to be away from your part, but also make sure that this value is not too big. So if I switch to millimeters and go back to IntelliCam, right now, for example, I only have 0.5 mil. So it's just because I'm not expecting my tool to be off by 0.5 mil. So I know that that will minimize the chance of once I'm leading in that the tool is actually touching or damaging the part. So that's why I always like to have a little value under approach offset. And when you use the approach offset value, it's good also to check your margin. So your part spacing type would be, for example, the tool width plus the offset plus a pad. So the tool width will be your nominal spacing. It will also add the offset that you set under the IntelliCam value, so the 0.5 I added, and plus a whatever value you want to add as more room between your parts. So right now I'm in millimeter, so I have 1 mil. So basically right now I have 1 mil plus 0.5 mil offset plus my tool width. That will be my tool, my part spacing when I'm nesting using this machine. Some people like a fixed one. So the fixed one will mean that you have to make sure you keep the same tool, or at least you're not going back and forth with a tool who have like a big difference in diameter. Or some people go just with tool width and pad. But typically me, to make sure that nothing is touching each other, I go with offset plus pad, including my tool width. And the margin, of course, would be whatever pleases you for the merging around the sheet as well. So those are the essential setting for a nesting machine you want to look for. The other one, I'll say, if you're unsure, don't change them. Again, they could create issues or introduce issues with your machine. So those are the ones that you would be able to change. So now, if we close this, second thing we want to cover, it's so the tools will be accessible with the tool button in the catalog toolbar. So that will open your tool catalog. So in your tool catalog, you can manage the existing tool by selecting them in the drop-down list. So this will display all the tools. You can filter them by machine. You can, right now I'm looking at the tool for any machine, but if I wanted to only see the tools for my drill and dowel machine, I can just select the machine, and then I'll see that this drill and dowel machine only has 2 tools in CAMLation. So I go back to any, and also you can filter by tool type. So you can say, let's say you only wanted to see the flat router tools, so you can now filter down as well. I'll go back to all if you want to see every single tool. You can create new tools, of course. You can copy existing one or delete tools. Sometimes it's always good to copy an existing one and create a new version of it. Also, when you create or copy a tool, very important to set first the machine associated with the tool. So right now, this tool is not associated with any machine. So multiple is what's set, or it could be also unavailable if you want to completely turn it off. But if I go to, for example, my 𝗶𝗰 compression, you see that this one, my machine is set to multiple, so I can assign it to multiple machine and then check which machine will be using this tool. So right now, this 𝗶𝗰 compression, I have the name set to 𝗶𝗰 compression. Every name has to be unique, so 2 tools cannot have the same name. The tool number will depend if your machine needs a tool number or not. Usually there's 2 big family of machine using the tool numbers to identify the tool to be used, or machine using the tool name to find the tool in the tool magazine. So that depends on what you use. If you're unsure, reach out to your CNC tech, or even your CNC operator might know the answer. So if it's tool number, make sure you properly set those tool numbers. So in CAMLation, technically, they don't have to be unique, so you can have multiple tools with the same tool number. But in reality, make sure that you properly set them. So I would recommend to have them all being unique based on their position in the tool changer on your machine. The height offset ID is not used unless you are being specifically told to use it. So most machines don't need this setting, but some will use it. Then you will set the diameter. So I would say the majority of the tools in CAMLation work using what we call a tool compensation. So when you use a tool compensation, what you set here will be the actual, let's say, nominal diameter of the tool. So when you buy it, what is it sold as? So if it's 3/8, you set it as 3/8. But even if you sharpen the tool and it become a little bit smaller, the operator will actually input the real diameter of the tool, but make sure this will be smaller than or equal to the diameter of the tool in CAD so because you sharpen, so it should be smaller, not bigger. So CAD will actually say, my tool is spec as 3/8. The operator say, okay, it's 3/8, but it's a little bit shy less, so you will adjust it on the machine. And when you use tool composition, it's when the program is being run, the machine will actually look at the real diameter of the tool and compensate the position to actually move it slightly to actually get the right position for you. And that's why it's important that on the CNC machine, rule of thumb, and that's really important, the tool will be even equal to the one in CAD if when we measure it, it's exactly the same, or smaller if we sharpen it and it become a little bit smaller. The smaller to, I would say, there's a limit. It shouldn't be smaller, like, for example, an eighth of an inch off. It should be like some very small value. So for example, if we talk in millimeter, if my tool is 9.5, I would say anything up to 9 millimeter will be acceptable. Half a mil will be, or else there's a big difference. So you might want to adjust it in CAD as well if it's constantly way smaller than what you think it is in the software here. So that's for the tool diameter. The minimum work depth is to force an operation to be at a minimum depth. This will introduce mostly for compression tool because the compression tool, the way the tool profile is done, if you don't cut deep enough, it could chip the top of your material. So that's kind of to prevent this. So for example, if they say that you have to cut at least a 1/4 inch deep to make sure that it's not pulling the material up. So that's why you could use this minimum work depth value. The work depth is actually the maximum depth this tool can reach for an operation. So that will be very dependent to your tool, tool holder, so the way you install the tool. And if, for example, I was trying to create an operation over 3 inches, this tool will not work. So that's what this value is for. It's a maximum work depth. It doesn't mean that the tool cannot cut it in a single pass. It's really like the maximum it could cut based on the profile, the length of the tool. After that, we have setting for the tool selection. So the tool selection is based on 4 settings. The first one is to specify if you want CAD to auto-select the tool or not. So auto-select means that based on your design and engineering, CAD might use this tool based on its specs. So for example, if it's set as an outline tool or if it's set as a down shear or up shear, and based on its diameter, CAD will actually identify which tool will work best for specific operation. So to help us with that, created a little graphic just to kind of like refresh what are the different type of bits you will use on a machine, and mostly nesting, but it could be also for point-to-point as well. So there's 3 different family of bits, like flat router bits, the up shear, the down shear, and the compression. So the down shear, the one in the middle, so this is the one that will leave basically the crisp edge at the top of our material. So when we machine from the top. So this will guarantee that this top is not damaged with chips. So this is what the down shear bit will do. The cons of it is when you do that, because you want to preserve the top, the tool profile will actually push the chip down to evacuate them from the bottom. So that's why this is not a tool designed to cut through, at least not in a single pass, or it will be very difficult. You will have your chip being stuck at the bottom, and you will create issue with finishing, even moving part, because there's no space for the chip to exit the bit here. So that's why the down cut is really good for just dados. If you do like a 1/4 inch, 1/2 inch dado that's not going through, because you don't go very deep, this will guarantee that your dado doesn't have any chip at the top, but also the dado is not deep enough to get the chip stuck at the bottom. If you're going like in one shot, for example, 3/4, as you move, you will see that there's more and more and more buildup around the tool, and then that could damage, break the tool, or make the part move because the chip will try to expand around the bit here. So that's the down cut bit. The up shear, as you may guess, it will actually exit the chip from the top. So this one is really designed to evacuate the chip as fast as possible. So because of that, if you want to preserve the top of your material, this is not a good choice. It will actually pull the material up as well because it's a very aggressive tool. This is mostly designed when you want to cut fast. And fast, but it doesn't mean cut just anything. A good use case is for plywood. Let's say you do die wall where the structure is made of plywood, so you don't see it. It's all behind finished panel. So you just want to build a structure. So what you can do, you can use this up shear tool because you want to cut the plywood as fast as possible and you don't want the material to overheat. So you can use it. So you will see that it will chip a lot, but because it's just to build a structure to hold a wall, it doesn't mean that it doesn't need to be perfectly finished. So that's what you will use it for, upcut bits. And the first one is the compression one. So the compression basically will pull the material up and push it at the same time. So the chip will be evacuated toward the center of the bit. So what happens is you have a downstream profile at the top of the bit and an upstream profile at the top of the bit, and then the chip are evacuated through the center. So when you use this, it's really designed to create outline cut. So to cut through your part with good finish, with where you minimize the chip on the face, but also minimize the chip on the back of the part. And also because at the back, at the bottom of the profile, you're pulling up, it will also help to evacuate and preserve the back of your part as well. So this is really designed for doing outline. So depending on, again, the way the tool is done, I see some clients using compression for a down cut when they know that it's deep enough to actually work with the down shear section of the tool. So it's a good tip if you want to save one tool change. You take a compression bit that has a low up shear profile, and most of it is down shear. So then if you have a data that's, let's say, 3/8 deep, it will work with this section. So it will actually give you a nice finish at the top using the same bit. So it's a few seconds saved, and it's also still going to give you the same quality as a down cut bit as well. So that's for the tools. So back to S2M. So this is all control under the tool section. So you can specify if it's down shear or up shear or both. And depending on what you select here, that will help CAMvision to decide if it's a dado, you will tend to use a down shear. If it's a outline cut, you will want to use compression. So compression will be yes and yes right here. And if you want, you can also create multiple tools and with different settings. So if I look at my down shear, you'll see that now this is just set to down shear. This is not an outline cut tool here. So each tool will have its own setting here. So that's something to make sure you set properly. And once you set this, so you set your setting in the tool, you also want to check your material properties. So this will be in the material manager. For each material, you can set if you want to minimize the face chip or minimize the back chip on the material. So if, for example, you do plywood, you can set both to false. You don't care what is minimized. And in this case, if you have an up shear tool, it could be used to cut this with an up shear tool if it's set to no and no. And of course, if you have finished two-sided material, you want to make sure those are both true. So this will tell S2M to use a compression bit. The way S2M will automatically select a bit, especially for an outline, it will, if you have multiple outline bits available set to yes, which you shouldn't, but try to have minimize how many you want as set to outline and auto select. You will try to use the one with the biggest diameter, just because the bigger the tool, typically the faster you can cut, and also it will last much longer as well. So that's for the material properties to set if you want to minimize the face shape or the back shapes. After that, on the tool, one thing you want to set, so typically leave the output path to the default setting. It's always pretty much set already, so you want to use a tool compensation. If you want to rotate clockwise or counterclockwise, that's something that you can control here. But if it's for the material, you have and there's a note here. If you want to climb cut, it will be at the material level. You have to go on the sheet and set in the material properties if you want to use a climb cut. The maximum depth per pass is the value the tool can cut in a single pass. So 3 means in this case, it will cut up to 3 inches in one single pass. But if you make this less and you try to cut deeper, that will trigger to create a second pass or third pass, depending on how deep you're trying to cut. The add to through cut is mostly used for outline tool or any tool that will cut through your material. So if you want to cut through your material in CV, the operation will have to be equal to the thickness of the part, and CV will automatically add the extra value you set here. So if I look at my compression tool and I scroll down to add to through cut, so here it looks like it's 0, but if I go to millimeters and set to precision, in millimeters is 0.15 millimeters, or in inches, if I go 64, it's still 0. It's a very small value, so you have to go with decimal to see it's 0.059 inches deep for my through cut. So that's how much I'll get my tool to go into my spool board. Quick tip, sometimes I see people doing it. They set this to a minimum, a negative value. Use it carefully, but the reasoning is if they wanted to onion skin everything and just leave a little skin. They didn't want to cut through, so they set this to a negative value, and that will actually lift the tool up instead of going deeper here. Last section, the feed rate. So the feed rate, you have the feed rate, the descent rate, and the spindle speed. The spindle speed is how fast the tool is actually rotating in the spindle head. This is a setting that you'll find with your vendor, so the tool vendor. The feed rate, same thing, they have some recommendation which you can apply in CV. So the way CV apply the feed rate, it will calculate basically an equation based on the 1/4 inch feed rate and the 3/4 feed rate. And the 1/4 and 3/4 is an actual depth. So it will say that if my operation were to be a 1/4 inch deep, my tool will go at 800 inches per minute. If my operation was 3/4 deep, my tool will go 800 inches per minute. Here it's equal, but if I take the example of, let's say, a 1/2 inch down shear, you'll see that here what's happening is if I cut less deep, my tool go faster, but the deeper I go, the slower my tool will go. And that's really meant to not go too fast if you're trying to cut deep with this tool. A simple explanation, just more like a little graph. It's easier to understand. If you have a 1/4 inch, this is your feed, so you go faster, but if you go deeper, you tend to slow down your tool. So that's more if you want to have more like a dynamic feed where it will automatically slow down based on the depth you go. Often we have user will simplify this, and simplifying means is similar to what I had on my compression bit where they want to cut everything at the same speed. That's again something you want to check if it makes sense in your use case, but often I see people just putting the same value, and here my feed is locked to 800 no matter how deep. And for the compression, it makes sense because this tool will only use to cut through, and I typically always going to cut about 3/4 of an inch of material at once. So I kind of know that I will cut this, and I just set the nominal value, the optimal value for this speed, because I'm rarely going to cut this only a 1/4 inch deep. And the descent rate is when you're leading in, you can slow down the tool. So here, rule of thumb, if you're not sure what to put, just put half the feed. So you want to go slower and just half the value is a good starting point. That will create a gentle lead-in, and then once the tool reach the full depth of the operation, it will pick up speed and now go to the speed that you set under the feed rate here. Okay, so that's for the tool properties. And of course, different tools have different properties. So for example, if I take a 90-degree V-bit, you'll find a lot of the same setting, but also this tool, because it's a 𝗲𝗀𝗶𝗃, and this is under the type, if I create a new tool, 𝗲𝗀𝗶𝗃. This one will also ask me to set the cone angle, for example. It will also ask me to set the nest gap padding. And if I go in inches, so this is a useful setting. If you cut a miter, and also depending on the size of the tool, this one is quite big. It's 1.5 inch 𝗲𝗀𝗶𝗃. I want to increase the gap between my parts just to make sure that they don't touch each other's. The nest gap padding, and this is only applied when CV is automatically generating miters based on the part shape. If I look at my example, if I go back to my report, I have a base column. So if I edit this base column, so this base column is a little bit custom, but it has a trigger where I will turn off the fold CNC. It's just a parameter I created because I want to fold it, but I don't want to fold it on the CNC. I just want to create a basic. So this one will create automatic miters, and those parts might be all over the place on my nested sheet because I'm not planning to fold them. So if I do it this way and show you, because I set to have my 𝗲𝗀𝗶𝗃 to have a 3/4 nest gap padding, it should automatically increase the space between those parts on my CNC. So we'll test it right away. I'll filter and I'll find my column, and let's nest the column, run. And as you can see here, this is not my typical. Usually I should have like about 3/8, but here CV did increase the space for those parts on the CNC. And I believe I have the simulation. Yep, I can run the simulation here. And that's this 3/4 is just to make sure once I'm cutting, and also I set to have a maximum depth of 5/8, so you will do 2 passes. And here it doesn't, a little bit more than 2 because the tool needs to offset itself to actually create the profile around the edge. So let it finish. Here we go. And now my 3/4 was just to make sure, and it's probably a little bit too much. What you want is to minimize this between your parts, just so you don't have like a strip here, but you want to make sure that when you create the miter here, it doesn't damage the part next to it. So here, I guess I could go probably 5/8 or 1/2 inch will be enough, but I just wanted to show you what this will do on the CNC when you do automatic miters with assemblies. And if you never did that and you installed a tool, a thing to know is in S2M, there's a setting to turn on. So when you're in S2M, you go under Files, Preferences, and in the Preferences, you go in the CNC tab, and you have a section for miters. So when S2M automatically create miter operation, by default, this setting is off. So it's not automatically creating those miters for you. So you want to turn it on. And usually I recommend to turn on those 3 options: allow miter on concave and safe edges, and use V-bit tool if angle matches miter. So those 3, you want to make sure you set those, and then you will do just what I described to have the miter. If you draw a part and in the shape editor, you change the angle to a miter that will match your tool, then you will create the operation on your machine. So that's for those ones. And also this one, as I said, it's only when it's done by the editor. But this here, and just a very quick explanation, because here I have a kind of like modified this to my own need to add an option to fold it. And when I set fold, I basically tell my CV to not output this, but output something else instead, because I want to fold this. So you will output a custom part, but this will not increase the gap because this is a manually created part with manual operation on it. So now it's on. And if I were to nest it again, you'll see that it's a completely different result, but that's just a modification I made for this assembly for my needs. But the takeaway is to make sure that you only do it for automatic edge if you want to increase the gap. So if I go and optimize my folded miter, so now it's basically for my need, it's only one panel where there's a bunch of operation just to fold all this on the CNC. It's the same size, it's all parametric, but if I were to just go, here you go. And the difference is this one doesn't go through because I just want to fold it on the CNC. And this doesn't need to increase the gap because it's a user added operation of it for it. So that's for the tools. You're free to explore the different tools you'll find. So different tool has different settings, as I said, but more so it's very easy to navigate what you should set based on your tools. Now, let's talk about materials in S2M. So when you're in S2M, so by default, you're always looking at the part view. So the part view is the default setting. In the view toolbar, you can switch from part to material. So material means that you can see the actual material that could be used for this project. So basically, based on the part, CV will already look at your tool and material library and pull the materials as well in the list. The good thing is you can also come here and modify size of your material. The quantity is always set to 999. So for CV, because CV doesn't manage inventory, it's virtually like unlimited material. But if you want, you could also change this quantity manually. And the reason why you want to change it is you could add your own new material just for this project. This is not going to create an actual sheet in the material library. It's just for this project. So I want to add a 3/4 2S maple, and I want to make it 120 by 60. And I'll say that I have about 5 sheets of this, but the 4x8 only have 1 sheet here. So I can manually change the quantity. If I go back to my part view, I'll try to optimize everything. So check everything, and I'll run the optimizer and see what will happen. So now the algorithm will try to nest all those parts. And once it's done, I will be able to see the summary. So in the summary, you'll often see some warning, and those warning about tool being assigned. They're not really errors, they're just to let you know what tool will be assigned for specific operations. That's more when you have auto select on. So most of the time you want to pay attention just if this is a new type of part you never did before, but this is just for your own information. It means that S2M will do it with some auto selected tool. So now if I select my 3/4 maple ply, so here I have 60 by 120. And if I go through, so now it only uses 60 by 120 for everything. Oops, actually, no. Here it found one sheet with a good yield where it could maximize the yield on the 4x8. So that's just to show you that you can change the way CV will optimize material based on the size. So you can actually pull material. Let's say you have offcuts, you have like different sheet size. So you can override this. And this is just for this session. So if I go back to my plan or elevation view and go back to my S2M, that will reset all those changes. So as I said, this is not creating permanent material. This is just before optimizing that you can change the material being used for your parts. So this is under part and versus material view. Another thing you can do here, very useful, is to select a material and right click on it. And you have on the wheel a couple of options. So you can delete the material. So it means that you don't want to use it for this current optimization. It would just mean that don't use this to cut my part. Sometimes I will pull a different material and remove the old one. Or you can go in the properties of the material. The properties will allow you to override some setting, the way the pattern is generated for this material, the trim for this particular material, if you wanted to have a different trim for this type of material, or even the way the offcuts are generated, like the minimum width and length for the offcut, or if you want to square off or not the offcut for this material. The one that I like a lot is the tools. So you can, instead of auto-selecting the tool that will use the same tool as every other material based on the S2M tool setting, you can actually set a specific tool just for this material for machining the material from the face or from the back. So what I like to do, for example, here is this plywood. I can say, you know what, I have a compression bit just for plywood. It's called 𝗶𝗰𝗃𝗃𝗃𝗃, which is the last one here. And what I will do, and here I don't have to save anything, I just click OK. You will see that a little red check and a tool symbol will appear. So that's letting me know that there's an override on the material, and this override is a tool override. So now moving forward, every time, and this is something that's going to happen for every job moving forward, so you don't have to do it over and over. It's automatically saved. This material will be using this 𝗶𝗰𝗃𝗃𝗃𝗃 bit. And I only set it for this material. So if you want, you have some material that should use specific tool for outline cut, feel free to go in the material view, right click, go in the setting, and now you can change the tool you want to use. Be careful, because if you don't want it, you have to remove it. So if you're done, let's say it was a one-off thing, just right click on it, and you have a button to remove tool override or remove override. Override and tool override means override will be more like if you created override for the trim, the offcut value, and tools will be if you set override for the tool here. So here I remove the override, there's no check, and this is just going to use the standard material I had before. Also, you can change if you want, turn off the grain if you want the part to rotate freely on the material, you can turn off the grain. If you're looking for even more control on the material, this is already great, but you can even go one step further, where you can go in the Utilities tab, and you have a material catalog in the Utilities tab. This is an S2M Utilities tab. And what you can do, you can actually go in the CV database. So you have a show material from CV and pull any material you want. And here I already have a few in my list, but you can add more if you want. So let's say I want to add a 3/4 particle ball, or say I want to show it in my S2M material catalog. So now it's part of it. And what it will allow you to do is also this one, you can actually change settings for each tool individually for each material. Let's say, just for an example, this particle board, because this is just some scrap, you save, for example, when I'm using my 3/4 compression, you can turn it on here. You can say, you know what, increase my feed or my descent, so cut faster or slower here. So you can really change all the setting per tool, per material, using this view, the material catalog. Also, you can select the same way we did before. We can select tool per material. But the great thing is also you can go even one step further. You can select one tool per material, but also per machine. Here I only have one flat router machine, but let's say you have 3 machines, and 3 machines have 3 different tools. So you want to tell CAMvision, for this material, cut it with the tool 105 on my machine A, cut it with the tool 120 on my machine B, so you can do it in this view here. So that's why I say there's a lot of things to play with by just going to this view here. Also, you can show the advanced tool, try to just hide it. So this is what we see here. Or you can also add additional material size. So if you want to also say, I also have 4x8, 5x9 as well, which now can somewhat be done at the material level. So this is less used, but those tool strategy and outline tool are really much the most important one. Set the tool feed and speed per material for each tool, or change the outline tool per material, but also per machine as well. So that's what it does. Last thing in the S2M view, if I go back to my part view, is the fact that you can import CAD file. So in 𝗧M, you can import a 𝗧xe file. So importing a 𝗧xe file is importing it straight from the CAD file to the 𝗧M without having to draw it in the design in CAD. So when you import a 𝗧xe file, what you want is to properly set the layers. So each operation has to be on a layer, and the layer name will actually dictate how CAD and 𝗧M will interpret this operation. So if I import now a CAD file, so when I open the window, the very first thing is you want to check your what we call a layer scheme. The layer scheme is basically the way you map each layer for different type of operation and different type of parameters. Very easy way to understand is based on the name, CAD will know what to do for the geometry. So if I have one called default, and I'll open one file, this is a bathroom sign. So this is something I drew in my CAD file, and I actually associated my outline geometry, my outline cut, to a layer called OT in the CAD software. So what the OT does, so if I go look at my setting, I just click on the edit to see the properties of this layer scheme. I see that if I want to define an outline, I have to associate the geometry with the layer called OT, and that's why CV knows. So of course, if you have outline, make sure only one geometry is associated with the outline. After that, I see that I have something called 𝗶𝗰𝗀𝗂𝗱𝗃0P25L. So basically, this is all my machining I want to do. I want to pocket this in 𝗧M. So what I did, I created a layer where I associated my entire geometry with a layer that having the name starting with PK, and PK is because in my layer scheme, I said that if it starts with PK, I want to create a pocket, and then I will define the type of operation and then the parameters. So after PK, you can put a T. You don't have to. Those are mostly optional, but it just depends on what you want to do. So here T means I want to use a specific tool, and you use the tool number, and the tool number is the one you type in 𝗧M. So right now I've said this is T, and I put the tool number 103. Then the D is for depth. So that's where I want to define the depth of my pocket. So when you put the depth, the first thing you put first the first digit of your size, then the decimal separator, and then the decimal number. So basically, if you have 0.225 inches, you put D0 for the diameter 0. P is my decimal separator, and then 25 is the actual decimal value. The reason why you have to put the P is because in a layer name, you cannot put a dot or any special character, so we just assign a value here. And then the last one, in this case, it's not something you must add because it's a pocket, but you can also set the tool compensation if you want to cut on the left or the right of your geometry. So here I just said cut on the left just to be safe. So that's what this layer does, and of course you can create your own or you can modify. You have a couple of examples. So that's how it will interpret it. One thing also you can do if you want, you can modify the layer name directly in 𝗧M. So let's say you imported it and it was done wrong and you don't want to go back to your CAD software, you can click edit and you can retype it here if you want to. An example, let's say, for example, I say instead of pocket, I'll say it's a PKT. This is how I call my pocket. You'll see that now CV will know that. It will rename it automatically for you. You'll say, oh, now it's PKT, so your layer should be called PKT. But if I edit this and I just call it PK and click OK, it will be red because I override it, and you say there's no matching data because in my layer scheme, nothing has the name PK. So I'll just put PKT, click OK, and now it's done. And then set the unit of your drawing. Select the material you want to use. Let's say I want to use maple ply. And when you click save, this will add it at the end of your part list. So this will be added at the very end. And let's say I want to machine a few of those. So I have it here. And actually what I will do, I'll machine everything. And right now I have quantity 1, but I'll say that in the other column right here, I'll say I want to add an unlimited amount of them. And what other does is means that if you have space on your sheets, try to add as many as you could up to 9999. So that's what it does. So now this is for the 𝗶 maple ply. So let's say I will nest all this. So now I'm optimizing the maple ply. So even if you put a large number here, it's not going to call a new material just for this part. It will only look at empty space to add it if it could fit. And we'll see how CV optimize this run now. Okay. So as you can see, I still have 6 sheets of maple ply. So I didn't have the support to add like 100 of sheets just to add those. But if I go through my sheets, see here, I have an empty space. So it did say, oh, I can fit it here. And at least I'm not wasting material. And I can keep going here. For example, this is the last sheet. So the 6th one is instead of having half the sheet empty, you said you wanted almost 1,000 of them, but I could fit a few here for you here. So that's what the other column does. And also it's allowing me to show you how the CAD import works. So if it's properly done, you'll see that what you have in your CAD file will be imported in your 𝗧M directly without having to redraw it in CAD. And we can run the simulation. So here it's inserting the machining. There's quite a few parts, so that's why it takes a bit longer. And by the way, the simulation is an add-on that could be added to your 𝗧M. This is something you can add if you want to run simulation in directly from CAD without having to do it on the CNC machine computer. So now we have it, and I'll just go full speed, and you can see now it's machining. And if I pause, you see, oops, actually I went a little bit too fast. It's already skipped it, but it was using the 1/4 inch because that was my tool 103. So it did also pull the correct tool as well for this operation too. And I can just complete the rest and see the end result. And again, I have a miter for a toe kick here. That's also required. And this is dados as well. So that's the general setting of 𝗧M. Very last thing before we go to question is when you are on the cut pattern view, a couple of things you can do. So you can select a part. It will, of course, be highlighted on the list. You can right click, and there's different things you can do. You can cut, copy, or paste part. So if I say I go on this sheet and then I right click and copy this stretcher. So I'll hit copy. So when you're copying it, it will go in a clipboard. And to see the clipboard, you click on the little clipboard icon where you have the part list. So you have even the part list or the clipboard. And then you can drag and drop your part. And in this case, I just don't have the space because it's part of a group. But you can drag and drop it, and you will reinsert it in your nesting. When you have the clipboard, so you can add as many parts as you want, so you can copy and it will just be added and just waiting for you to insert it wherever you want. What you can do too is when you want to add a new sheet, so let's say I have those 6-1, but I forgot something or I want to copy something, you can right click directly on the stack and you have an option to add a blank sheet. And you can set here, I have different sheet size, so I say I want to add and 4896, and now you can add part to this sheet. Typically when you do that, 𝗧M will not let you add a part from a different material to another one, so you have to make sure it's properly assigned for the right material. So that's how you can add a blank sheet. And of course, if you want to output this to the nesting machine, you click NC code and you can output based on your default path. The very last option is to save the job state. And this is a useful feature if you want to save this nesting and reopen it later. Let's say you wanted to reopen it, recut something or you want to make a change. So that will create a file, a backup file. So here I can click run and also just copy the path. And this will actually, while I'm outputting my file, I will have an exact copy of this nesting with the exact same sheet count optimization as well. So that's very useful if sometime your operator want to reopen it and maybe recut something. So it could reopen and it will keep the same run number as well. So once it's done, we'll see, I'll show you where to reopen a saved optimization. And the save optimization will create a SNC file. And the SNC file is a copy of your optimization in CV. Okay, almost there. With the engraving, it's a little bit more work for S2M. And also there's a bunch of curved parts so as well. Okay. This is because I have also a point-to-point machine, so I have probably flip operation, and I have also a dowel machine, so my dowel program I created. And if you want to quickly see the part, you can change in the view. You have a view button when you switch to part view, and you can see what part goes to the point-to-point. And in the drop-down list, you can see what part goes to the dowel machine. So for me, that's a good way to confirm what is going where. So I can see the entire workflow, nesting first. Then in part view, I have some part going to the point-to-point and some to the dowel machine to drill those dowels. So you can switch from pattern view to part view. So what I wanted to show you was re-importing the optimization in S2M. So it's just refreshing the view. So let's give it a second. Almost done. Here you go. Click back. No, I don't want to save the offcut. And if you want to re-import a saved optimization, you go in the Utilities tab, and that'll be Import NC. And now in Import NC, just go back to where you saved it. And actually, I said SNC. That was the old format. Sorry, it's SNX now. So you can click Open, and this will reopen the same optimization you had before. So that's going to go back straight back to the actual part view on the sheets where you can see how you're optimized before here. So that's really all I wanted to cover in this hour. I'm 4 minutes late, sorry about that, but I'm sure it was totally worth it. So I'll get back to Amanda for questions now.
Thanks so much, Christopher. Definitely worth it. We've had a great conversation going in the chat. So there are a few questions that will require follow-up afterwards. So please, everyone, if there's something that we don't get to today, we are recording the entire chat and we will get back to you after the webinar. But for now, Christopher, there's just a few that we could address as a group. So the first one is there a way to keep the part number orders when using TrueShape nest type? Without label it, this amazing feature becomes a nightmare with sheets containing several parts.
Very good question. At the moment, no, unfortunately. The TrueShape will actually try to find a matching position across the entire sheet. And you're right that the numbering will be much less easy to follow along than block nesting. And that's really one of the reasons sometimes if you don't need TrueShape, maybe don't use it all the time if you know it's mostly blocked, like let's say rectangular parts. But no, there's no way to renumber or actually force the number to be moved to a specific position.
Perfect, thank you. All right, the next one is, can you show us an example of a nest pattern with small parts using boundaries? Seems when we try it, the optimization is not good. Also, is there a way to leave the tab and not have them get cut away?
So the second part of the question, unfortunately, no. The tab will, by default, by the design right now, be cut out at the very end. There's a request, an enhancement request already. So go make sure you go on Nexus and maybe vote for it. Hopefully future update would add this feature. Now for the boundary, so let's do a practical example. As I said, I'm using a true shape nesting, and right now exterior, so I'll put, for example, 4 and 4. And I will filter or just cut cabinet parts. Just standard cabinet part where I have more chance to find small stretches. And let's run it. So my small part will be anything under 6-inch wide, if I'm not mistaken. So if I go here, so here's a good example. Those will tend to be more in the center toward the edge. And again, surrounded by other parts. So this is good. Here we can really see what happened. So there is the space, but CV did offset them a little bit on the sheet. So if you don't get this exact result and you tried everything, maybe just send us a request and we can connect with you to see if there's maybe another setting preventing you from having the boundary to work.
Thank you. Again, for anyone who has to leave, don't worry, we will be sharing a recording and following up afterwards. So Christopher, maybe I'll give you 2 more if you have time. So this one is, can you control cabinet parts being nested together versus spread over all sheets of the nest? Best yield versus easy sorting.
The setting I know is the to nest by cabinet versus just nesting freely. So that would be when you go back to the USTM view, if you go in the preferences, under the ordering, you can say you want to organize it by cabinet. You can do by cabinet or overlap cabinet by. Cabinet will be a very strict nesting where it will keep all the parts from a cabinet together. So cabinet 1 will be cut all apart, cabinet 1 on the same sheet, where overlap will actually, and you put the maximum amount, will say that for cabinet 1, if I put a value of 3, it will actually cut the part for cabinet 1 over 3 different sheets, a maximum of 3 different sheets. So it's less spread out. And that's mostly used if you run in a production where you want your part as fast as possible and almost want to already like building and assembling the part. So that's what you can use. Even a strict one if you really want all those parts to stay together, or overlap if you want them to be spread out across maybe 1 to 3 sheets. Be careful, this one will give less good yield, so you might see that your optimization will suffer because there's less chance for the algorithm to find a nice optimal optimization.
Great. So I'm so sorry, this has to be our last one. And this is about saw operations. The question is it possible to have our saw blade activated by CV?
Yes, absolutely. If you have a nesting machine with a saw blade on it, so first you can create a tool, a saw tool that could be associated to your machine. So you create a saw, call it saw 1. And then you can associate it with your machine. Let's say it's a router. Sometime, and it depends on your machine, if you already have it and nothing's happening, in CV, there's a few things that might cause it. So first, if you wanted to use it for dados, you have to make sure you select the auto select on stop dado. Let's say you have a groove or a back, but it doesn't go through. It's like kind of stop. So make sure you turn this on. And the second thing is, of course, you want to set the number, the feed rate, and every other important setting. In your post processor, sometimes we have to also make a change to activate the saw depending on the machine. Some machine is seamless. Some machine we kind of have to know what is the saw number and make sure that when we translate the CNC file to the machine, we also know what tool number this saw required. And also when it's a saw, you can also change the direction. So make sure you specify if you can cut in specific direction from left to right or any direction, for example. But the short answer is yes, it is possible.
Thanks so much. Bye, everyone.